Section 5.6 is on graphing inequalities in two variables. An inequality in two variables is going to have both an x and a y in it. Up until this point, we've only been dealing with inequalities that have an x in them and can be graphed on a number line. Since we now have an x and a y, these are going to be graphed on a coordinate plane. So in order to do that, we're going to graph the related linear equation. So in other words, just imagine that that greater than or less than sign is an equal sign. So graph that line. We're going to determine if the line is solid, and it's going to be solid if it's a less than or equal to or a greater than or equal to. The or equal to makes it a solid line. Or it could be a dashed line, in which case you'd have a less than or a greater than. So if there's a little line underneath, make the line solid. We're going to test a point that is not on the line and see if that works in the inequality. If the point does make that inequality true, we're going to shade that side of the line. If the point does not make the inequality true, then we will shade the other side. So let's take a look at a couple examples here. So here I have the inequality 4x minus 2y is greater than 6. In order to graph this, I want to put it into slope-intercept form. So I'm going to add, I'll write it over here so I have a little room. So I'm going to subtract 4x on both sides. So I'll have negative 2y is greater than negative 4x plus 6. And then divide both sides by negative 2 because I'm basically solving for y. So y, now because I divided by a negative 2, don't forget I have to flip my inequality, so my greater than becomes a less than 2x minus 3. So I'm going to start, well actually before I graph, let's take a look at this. So this is going to be a dashed line. Okay, so to graph this, I'm going to graph the line y equals 2x minus 3. So my y-intercept is negative 3. My slope is 2, which means I go up 2 and right 1. Or down 2 and left 1. And it's dashed, so I'm just going to put some little dash marks in between. And now I have to figure out which side of that line I'm going to shade. So I need to pick a point on one side of the line, plug it into the inequality, and see if it makes it true. The easiest point to use is 0, 0. The only time you can't use 0, 0 is when the line actually goes through that. So plugging in 0 for y, is that less than 2 times 0 for x minus 3? Is 0 less than 0 minus 3? Is 0 less than negative 3? No, it's not. It's actually greater than. So that's not true. So here's where the point 0, 0 is. Since it's not true, I do not want to shade that side of the line. I want to shade the other side of the line over here. So all of that gets shaded. Now what does that mean? That means that every point on this side of the line makes that inequality true. So if I were to pick the point 10, 10, 10 or 10, negative 10 and plug it in, it's going to work. And every point on this unshaded side of the line does not work. Let's take a look at another example. Here I have the line x plus y is less than or equal to 3. So again, I need to solve this for y, put it into slope-intercept form to make it a little easier. So I'll subtract x from both sides. So I have y is less than or equal to negative x plus 3. And because this is a less than or equal to, this is going to be a solid line. So I'll go ahead and graph that. My y-intercept is 3, and my slope is in negative 1, which means down 1 and right 1, or up 1 and left 1. And since this is a solid line, I'm not going to worry about the dashes. Just draw my line here. Okay. And now I need to figure out which side of that line needs to be shaded. I'm going to use my test point, 0, 0. because my graph does not go through 0, 0. Actually, if your graph goes through 0, 0, you might choose something else easy like 1, 1 or 0, 1 or 1, 0. Okay, so plugging in 0 for y and 0 for x. Okay, so is 0 less than or equal to 3? Yes, it is. So here's 0, 0. So I'm going to shade the side of the line that contains that. So that would be all of this over here. And when you're shading, go ahead and use a pencil and just make it plenty dark so I can tell what you're shading. So in this section, we took a look at graphing inequalities in two variables, and these are going to be on the coordinate plane with an x and a y. Basically what you want to do is, if it isn't in slope-intercept form, that is, if it doesn't look like y equals mx plus b, put it into that form, graph the related equation, and then decide if it's solid or dashed, solid if it's an or equal to, dashed if it's not, and then test a point and shade one side of the line.